For section 3.3, I will do 4 problems for you today. We're going to do one problem where we just evaluate a logarithm. We're given the base number, given the number behind it, using the change of base formula. We will do another problem where we're going to find the exact value of some logarithms without using a calculator, meaning we should probably use the one-to-one property. Then we're going to use the properties of logarithms to take one term and expand it into sums and differences or constants of multiple logarithms, like we did in the notes. And the last one we'll do is we'll take one that's been expanded and we'll condense it into a single quantity. So those are the 4 problems that I'll do for you today. The very first one, evaluating log base 1/4 of 5 using the change of base formula. Remember in class we said anytime you know the base number and the number behind it, you should be able to figure out what this is equal to. So this is kind of how the change of base formula works. We say, well, since I know these two things, I know it has to equal some sort of number, so I'm just going to say it equals x for now. And then I can switch any logarithm into exponential form, so the base number is 1/4. That would be to the x power is equal 5 if I use the property to switch from logarithmic to exponential. And then since I'm trying to solve and my variable is up in the exponent, a lot of times we're going to take the log or natural log of both sides. Remember, it doesn't matter which base you use, if you use log base 10 or log base e. I always tend to use natural log, but either one would work. And the whole reason we do that is so now you can take x and move it out in front, because we have a property that allows us to do that. So it's x times the natural log of 1/4 is equal to the natural log of 5. And then this is just some sort of number, so if I want to get rid of it, since they're being multiplied, I just divide by it. So I'm going to divide both sides by the natural log of 1/4. Of course, it'll cancel over here. And an exact value would be x is equal to the natural log of 5 divided by the natural log of 1/4. That's not what we're going to be looking for. We're going to look for kind of an approximation. We're going to actually plug this in the calculator. I would like you to show that the change of base formula is not showing all the steps. The change of base formula is actually going from here straight to there, recognizing that whatever is in this position is going to be in the numerator here. Whatever is in that position, the base position, will eventually be in the denominator. You can change the base to whatever you want. Obviously, it makes sense to change it to log or natural log because those are on our calculators. But that's technically what the change of base formula is. So if that was the problem on the test, you wouldn't need to show that to me. You could go right from here to here. Or anytime you're doing a problem, you could go from here to here if you know the change of base formula. Now, of course, I just need to plug it into my calculator. And I'm going to plug in natural log of 5. I always go ahead and hit enter just so the calculator doesn't make any mistakes for me when I'm trying to plug in a bunch of information. Divide that by the natural log of 1/4, or I could of course say 0.25 because that is exact. Hit enter, and that would be my approximation, negative 1.161. I'm going to go to 3 decimal places. And that would be my answer. Alright, so that's the problem using the change of base formula. Second problem is going to ask us to find the exact value. So kind of like the first problem, only this time we're going to do it without using a calculator. So first thing I'd have to do is recognize, well, I have 2 different logarithms and they have the same base. So by using one of my properties of logarithms, I'm allowed to combine those together, and I would take these 2, and according to that plus sign, I would multiply those together, keep the base the same. So that's going to give me log base 4 of 2 times 32, which is 64. And if we recognize to do that, well, that realistically is no different than this problem where we did the change of base formula. Only difference is we're not allowed to use a calculator. I'm still going to do the same idea. I'm still going to say it's 4. It's got to equal something because I know the base number and the number behind it. 4 to the x power is equal to 64. And now this is like what we did in sections 1 and 2 where we said, okay, we're not going to use a calculator. We're going to get these 2 bases to be the same. So can I rewrite 64 as 4 to some power? And if you think for a little bit, you can say that yes, that is actually 4 to the 3rd power. And now since the bases are the same, you can just set the exponents equal to each other. And I know that this thing, whatever these 2 are, when I add them together, I'm eventually going to get 3. So anytime you see that in the problem where it says without a calculator, you should be able to switch to exponential, and then you should be able to do the one-to-one property. Alright, the third problem I said I would help you do is taking one single quantity and expand it out or break it down into sums and differences. So when you look at the logarithm, the base really won't make a difference here. It's just going to be the same base for all these logs that we write. But when you look at the problem, you want to identify how many different terms should I break this down into. And so you're looking for how many things are being multiplied or divided, how many quantities. I would say I've got one here with a 6, I've got one with the x to the third, and I've got another with the square root. So I would say that I have 3 different quantities being multiplied or divided. The radical is kind of like a big parenthesis, so that counts as one term. Alright, the reason I want to know that is I'm going to break this down now into 3 logarithms, happen to be natural logs. And it doesn't matter which one I write first, but I'm going to say, okay, I've got a natural log of 6, I've got a natural log of x to the third, and I've got a natural log of the square root of y squared plus 1. Like I said, it doesn't matter which one of these you put where. If you look back at those 2 properties of exponents, or 2 of the many properties we had of exponents, it said, or we looked at and noticed that anything that came from the numerator meant that that logarithm must have been positive. So this is positive. I don't need to put a plus sign in front here. It's the first term. It's implied to be positive. I don't put anything in front of it. The x to the third came from the denominator. That means this natural log is negative. And then this also came from the denominator. That means its natural log is negative. So again, 6 came from the numerator. That's why this is positive, implied to be there. Those 2 came from the denominator. That's why these are both negative. And now your last step when you're expanding is they don't want any exponents, so I'm going to take that 3, move it in front. This would be considered the constant multiple thing. If you wanted to plug it in your calculator, you could. I would actually just leave it like that. You look in the back of the book and they give you a decimal, that's fine. I'll accept that. Said you're going to bring the 3 out front so that I just have the natural log of x or y or z or whatever the case may be. And then remember that this, another way to write any kind of radical is to say that it's that quantity to the 1/2 power. So I'm going to bring the 1/2 out in front. And then because this is a quantity, I do need to say parenthesis y squared plus 1. It's a common mistake to do this, and I know what you mean when you do this, but these 2 things do not mean the same thing. That's the natural log of y squared, and then I add 1 to it. This is the natural log of y squared plus 1. So it seems like a minor detail, and I guess it can be, but this is right and that is not, so make sure that you're careful with that. So that's what your final answer would look like. And then the last one is basically just doing this, only working backwards. You have multiple terms and you're going to group them all together. And so now you can do this a couple different ways. It's kind of how you choose. I see that I have 1/2 in front of this bracket, so I'm going to go ahead and distribute 1/2 to the 2 terms that I have there. So doing that is going to give me 1/2 log base 4 of the quantity x plus 1, plus if I distribute 1/2, that would just be 1 log base 4 of the quantity x minus 1, and then I still have that 6 log base 4 of x. So all I did was simplify to start with and got rid of this 1/2. Alright, then the last thing I did up here was I took the exponent, moved it in front. That's now going to be the first thing I do. I'm going to take any exponent or any number in front, and I'm going to actually move it up to the exponent if I've got one. So that 1/2 and that 6 going to move to the exponent. So this is now going to become log base 4 of, this is x plus 1 to the 1/2, or remember we just got done saying to the 1/2 power is the same thing as the square root of x plus 1. Plus nothing, or there's a 1 to bring up, so that's not going to change anything. That's still going to stay log base 4 of x minus 1. And then bringing that 6 up is going to give you log base 4 of x to the 6. Just a reminder, because we saw it in the notes, when you have log base, let's say 4 of x to the 5th, and there's maybe a 2 out front, remember when you take this and you move it to the exponent, you're moving it to the exponent on this term. So it's an exponent on an exponent. You want to multiply those together. That would be x to the 10th, not to the 7th. Common mistake. Make sure that you're careful with that. Alright, not a part of this problem. But now that I've got all of the numbers in front to be 1s, that's going to allow me to group these together or combine these into one logarithm. I do want to double check to make sure all the base numbers are the same. If this was, say, a 3, well, then I could combine these 2 together and I'd have to leave that one by itself. But since they're all the same, I can combine this into one logarithm. And then what I tend to do is just scan them. Do you see a minus sign in front of any of these? I don't, which means I'm not going to have a fraction. These things are all in the numerator. Like here, when I looked at it, I saw there was a minus sign. That told me when I put them together, after I moved the 3 and the 1/2 in front, when I put them together, I'm going to have a couple things in the denominator. So that's why I'm looking for a minus sign here. Didn't see it, so I know everything is in the numerator, so I don't have to worry about putting a fraction bar here. And now all these things get multiplied together, and the order that you write them really doesn't make a difference. I'm going to write x to the 6th. I'm going to write the square root of x minus 1, and I'm going to write the quantity x minus 1, and that would be your final answer. Order, like I said, order those things how they're written doesn't make a difference. All right, that is homework help for section 3.3. Always welcome to come in and ask for help if you need it. Just a quick mention, if you wanted to, you could have combined these together right away and then take the square root. I tend to like to distribute first. I showed you an example of both in the notes. Kind of up to you how you want to do that.